Alright, I think we have the bits flowing and the stream started up after a few days off. Looks like we're live on YouTube. Are we live on Twitch? Maybe if I poke the reload button enough, we'll be live on Twitch. Yes, it looks like we're live on Twitch also. So hi, welcome back to the stream. We are currently broadcasting on Scanlime in progress on YouTube and twitch.tv/scanlime in case Twitch works better for you. And we're going to be back to our work on this kind of long, elaborate engineering project to put not quite a cat on the moon or even a cat anywhere comfortable. The cat's already got somewhere comfortable to be. So really this project is all secondary to the cat's comfort, but it's about helping all of you interact with the cat more. So that's what we've got going on here. This is the robotic camera hanging out with Tuco over there. And actually I thought we would open up the stream by playing with him a bit, because he was just demanding some playtime by meowing approximately every 3 seconds, and it looks like he's stopped for the moment, but I bet he'd still appreciate some bolts. Oh, did we lose tracking? Oh yeah, Tuco's got some good purring. Now he's going to want to play. Yeah, and so we can move around like that, and I'm actually pretty happy with the motion at first. And there's a little bit of like swinging near the end. Some of that is, just due to the nature of the system, the camera acts like a pendulum, and you've got to dissipate the energy slowly, or it's just going to mostly go into resonance in that system. So that's part of it, but I've got some pretty low acceleration limits set. I mean, we can certainly go lower. As far as I can tell, most of the wobble that you're seeing as the camera comes to a stop is actually due to the retensioning algorithm, which is not graceful right now, and it tends to jerk the cord around. Where is Tuco? I can see him in real life. There he is. Yeah, Tuco wants to play now. We can do some of that. So yeah, and there are a lot of directions we can take this project in. So we've been developing this over the course of a bunch of these videos at this point, and you can see a lot of the development work that's gone into this project in the existing video blogs. If you just search for Scanlime on YouTube or go to scanlime.org, there's a bunch of the more polished results over there. But there's also just a ton of just random engineering that's gone into this, and the different disciplines involved, from reverse engineering the gimbal to building this system of robotics, which involved mechanical and firmware, higher level software, and then sort of high level web front end kind of stuff, and control loops, which as you can see, and computer vision, various things. So yeah, there's been a lot going on, and we've been doing as much of it as possible on this show, really. And so the code behind that, you can actually find it all at github.com/TucoFlyer, just like the logo on the screen. And that organization has the main sort of robot control software written in Rust. It has the firmware written in C. It has all the CAD designs, which were done in Fusion 360 and Rhino. And it has like step files and like standard stuff in there. And recently there's also an issue tracker. Tuco is really going in there. I don't want him eating that plastic bubble wrap, but it looks like he's just in it for the bolt that's behind that. But yeah, so this cat, if you haven't seen, he's actually really determined to fetch these plastic bolts. And he'll go digging behind and under and through pretty much anything he needs to get the one particular bolt he's looking for. So yeah, we've had some pretty interesting sub-projects within this. The last edited video, the last like polished scanlime video that you can see is on the computer vision subsystem, and that tracks, well, quite a few different categories of objects. We're really only using it to track Tuco right now, but the goal there was to try to make some infrastructure that was flexible enough we could use it to also have other kind of interactions attached to objects in the shop. So right now we're mostly using that to detect Tuco, and then combining that with just a rectangle correlation tracker to keep finding him as he moves around in the scene, even between object detection results. And that works all right. There's certainly room for improvement in tracking him when he moves fast and doesn't really maintain a lot of coherence between frames. Tuke, did you give up on that one? Oh no, you have it. Wow, Tuco. Tuco, you're so good. Wow, okay. Well, we have to keep using this one. Where do you want this one to go? Good job, boy. Yeah, that was a good Twitter thread. The screenshot that Aiden just posted. Kawana on Twitter said, "You need to mod the Tuco flyer to drop bolts for him." And this is, oh, sorry, I just realized we lost tracking. Let me grab this manually. So yeah, Kawana said, "You need to mod the Tuco flyer to drop bolts for him." And this is something that comes up a lot, because of course we want an automatic bolt thrower for Tuco. So we lose tracking when that rectangle is on the edge of the screen, and it's actually overlapping a little gain rectangle where or not rectangle, but when it gets close to the edge of the screen, it starts feeding the PID loop and poking or pushing the gimbal in that direction. And yeah, so I replied, that's a different robot, because, of course, from the practical point of view, I think it would make a little more sense. As whimsical as it would be to have the flying robot itself also throw bolts, I think Tuco likes them better when they're thrown from kind of a low angle, and it also just makes more sense to have something that requires a stash of bolts and probably a fast rotating wheel to be on the ground. And yeah, just keeping the heavy robots on the ground seems to be where it's at in this project. So I was like, that's a different robot. But then MaceGR said, same one if you skimp on the Loctite, right? Oh, did that one end up in the water fountain? Or is it behind the water? I didn't hear it land in the water. Yeah, there are maybe some bolts that could fall out of the flare. They're certainly not supposed to do that. Oh yeah, so speaking of the flyer, I got the rest of the parts in the mail to make the lighter weight leash. So this will be a slight modification so that the flyer can reach more of the room without being pulled quite so much by the leash. So when we were first flying around that kind of dummy weight, the 1.5 kilogram spool, it was really easy to get to all the corners of the room we needed to get to. But now that the now that the robot is actually on there with the leash and everything, the leash is just pulling more than I really budgeted for, and I think the easiest way of alleviating that is probably just to make the leash as light as I can make it, and then just, you know, keep the counterweight as light as I can make that, and just give it as much extra cord as I can tolerate so that there's plenty of slack, and just generally be really generous with that system. And so right now the leash is actually pretty heavy because it's just like some standard monoprice Cat 5e and some speaker cable for the 12 volts. And I guess I've been sitting here like a dunce, like Tuco's way over there and the camera's way over here. I can move the camera. That's what this whole project is about, right? It's a little tricky to drive right now because I have to kind of manually do the height control. Oh, and one of the cords is too slack. Yeah, there's a bunch of stuff you have to kind of manually fuss with still, even though it's like a semi-automatic mode right now. Some of it's because the leash weight is annoying. That was an improvement still. Oh, hey, Took. Yeah, so the leash right now is Cat 5 power and video, and so I know everyone asks about this every time I talk about the leash. Everyone asks, why can't you just use Wi-Fi? Why can't you just, like, you know, use the tiniest possible wire for power and then put everything else over Wi-Fi? So I need like high reliability, high quality video for this project, which is not really a thing I can do over like normal, you know, wireless video equipment that I would be willing to spend the power and the dollars on for this project. So, because like if you're talking about Wi-Fi, that's not nearly reliable or low latency enough for this. And if you're talking about like FPV style, like 5.8 gigahertz stuff, that's not nearly high quality enough for this. So I want that combination of low latency and high quality, which is what you're seeing right now. And I only really know how to do that for a reasonable price with a wire. And so that's what really solidified needing a wire in the first place. And if you need to have a wire, then well, like, it's also super convenient not to have to recharge batteries, and then you can stream continuously. And so, you know, and then if you're going to have a wire for all that, then you might as well also use that for data, so you don't have to worry about the reliability and latency of Wi-Fi for sensors. So that's how we're here. And the original version of the leash was made just assuming that the weight didn't matter that much, since I figured that the weight of the flyer itself would actually be a bigger contributor, I think, and it's just light enough, relatively speaking, that the leash needs to be proportionately lighter. So that's what we're going to try at some point. I don't know if I'm going to do that on stream, because that's a bunch of like tedious work that's hard to film, but maybe I'll do that on stream. Anyway, that's where we are there, and I think the difference in the weight actually should be pretty substantial, because I'll be going from like a pretty chunky Cat 5e plus, what is it, like 16 gauge speaker cable, plus the relatively thin SDI. Oh, don't destroy that. And I'll be going to just the Cat 5, or sorry, just the, so I should get to what this wire is. It's like a super thin, it's the monoprice Slim Run Cat 6, which I think is 28 gauge stranded. So it's a little bit thin to use for power, but I'm going to use 2 pairs at 24 volts, so that'll be like half an amp, and that should be fine. The flyer doesn't need that much power. Most of that power is going into the infrared sensors and some of that into the gimbal motors. The camera is also kind of power hungry, but I'm going to bump it from 12 volts to 24 volts, and that should be good. Oh yeah, catching up on chat here. Where it says there's a smooth Q gimbal. Yeah, I don't know anything about what that specific product is, but like if you're talking about putting video through a slip ring, that's possible, but video slip rings are really expensive. And no, that's not what I did in the gimbal. The gimbal I'm using does not use slip rings. As far as I know, none of the like consumer grade like quadcopter gimbals would use slip rings. I don't think there would be enough space. The way they're made is with a hollow shaft, or like a hollow bore going through the middle of the motor, and the wires just go through straight through the center of the motor. So the wires are actually flexing every time the camera moves, and they'll eventually wear out and need to be replaced. Which will be tedious, but not the end of the world. Like, it's just like pretty normal wire in there. And the coax I ended up using is the 0.71 millimeter stuff that's usually used for Wi-Fi antennas. It's not rated for 75 ohms, but for this short of a length of it, it seems to work fine. And I just couple it to an SMA connector, and then I use like HD SDI security camera style kind of coax for the rest of the run. And that's pretty thin. So that plus the Cat6 Slim run, and I'll be using half the pairs for 100 base T there for telemetry, and half the pairs for 24 volt power. It's pretty thin. I've got a spool of it over here. Let me grab it. Tuco might try to play with it or something. So I needed about 150 feet of this, and Monoprice sells it in 6 feet and 1,000 feet, so I had to get the 1,000 feet. So this is going to be my standard Ethernet cable for a while now too. And it's pretty little. You need separate boots and crimps for it, which are probably sitting in my mailbox right now. So I'll get those in a bit. But yeah, 28 gauge, 4-pair. You know, it's standard compliant, so I don't know how they got away with 28 gauge, but it is Cat6. It is, what is this, TIA 568 C.2. So, yeah. Where is anything? There's anything. Oh, there's Tuco. What? Mr. Lendig is asking if this is copper-coated aluminum or copper. Of course this is copper. Why would Monoprice be selling copper-coated aluminum? Jeez. What do you think Monoprice is? AliExpress? What do you think Monoprice? No. No, it's 28 gauge copper. Like it's like UL rated and everything. I agree, power over copper-coated aluminum is not what I would advise either, but yeah, that's not what you get when you buy Cat6 from Monoprice. This is like actually pretty decent stuff. Yeah, but I mean, I guess that segues into a public service warning that, like, yeah, if you buy wire from like completely random no-name vendors, then they might be giving you copper-coated aluminum or iron or something else that you shouldn't really be running electricity through. What? I don't believe you. The same person in chat is saying that even Avaya sells copper-coated aluminum. I think that you're just being a troll, and I'm going to ignore you and stop reading your comments. Hey, Tuke. Uh-oh. That might have gone somewhere that he shouldn't be in. Can I distract him with a different bolt? I think he might already... Hey, Duke. That seemed unsatisfying. Oh, no, he took it up. Alright. That was good enough, just barely. Wow. You gonna continue destroying that, huh? I should put this away. Okay, well, we could continue playing with the cat all day. I do actually have some other things we could get into, though. Just catching up with the comments a little on YouTube and Twitch here. Am I even in the chat room on Twitch? My Twitch dashboard sometimes self-destructs. But anyway, yeah, hey, the Yeti and Nick on YouTube chat, and Mikey. Nick said the tracking's fantastic. It works pretty well sometimes, for sure. When it's having an alright time keeping him in view. Oh, there we go. I think I just had to collapse the... Twitch added this chat rooms thing recently, and it's uncollapsed by default, and I think my screen is so small that it just completely hid the regular stream chat. Alright. Oh yeah, that ADSL over wet string article was pretty good. Okay, what do we actually got to do? Let's turn off that overlay. I don't think we need that right now. So yeah, Tuco really did seem to need the play, but I think he's settled down a bit. Yeah, I think we've mostly gone over the status there. There's just a lot that's ready to do, and I've been trying to keep track of that in the issue tracker. We recently fixed a bug with the LEDs that actually turned out to be an endianness bug in the firmware. Specifically an endianness bug in the padding at the end of the frame. So it was, but it was still like, it took me depressingly long to realize what was actually going on, and it should have been obvious. So yeah, that was pretty cool. So now that that actually works, there's a lot we could do with LED animations, and I think I've got some ideas in mind. I've also been noticing it's just way too easy for me at the moment to just like almost run into this thing with my head, like when it's parked low. So it'd be great if I could use the X-band sensors to have it just either when something's approaching, flash the lights and maybe zoom upwards, you know, or both. So we could implement something like that. There's a lot we could do. There's just a lot of possibilities that open up in terms of using the sensors, and there's also more work that we need to do in order to just make sure that that data is actually as usable as possible. So the LiDAR sensors let us figure out how high we are above the ground, or just like generally whatever like flat object we're above. But that'll require some sensor conditioning in order to deal with occlusion, where we have something that's covering up just one of the sensors. We have 3 sensors, and so we can combine the 3. And we also will need to take into account the angle that the flyer is at using the IMU. So, for example, there could be a calibration step where you take the flyer and hold it at a single point and just like pivot it around, and then use those different angles combined with the distance readings to calibrate what specific angle the distance sensors are actually mounted at, and then use that model to solve for the angle later on, or the distance later on. Salt water, yeah. Well, you need some ions in there, otherwise... I mean, is it cheating to put the ADSL through some kind of like high voltage transformer first? Yeah, so this data will be more useful once we have it in meters and smoothed a bit, and with the geometry of the flyer taken into account. I don't know if I've demonstrated this X-band sensor, really. I thought that might be useful. Where is Tuco? I don't know if Tuco's here. I can at least just point the camera at the robot. I don't know what James means by this comment. Can we bugger off upward without having to solve the general problem of automatic movement? I don't know that I understand the question, but I think the answer is yes. I mean, there's this whole range of things that you can do that involve moving relative to the current like winch and cord geometry without having to know the full geometry of the room and everything. I think that's like where everything we've been doing is so far, and it's been working out all right. There are definitely limits to what that strategy can do, but going up, you can make a pretty good approximation of up just by setting all the winches to the same velocity, which is what happens right now when you just press that axis on the controller. And it's not perfect, but I mean, even that approximation of up would be good enough for collision avoidance, and we can certainly do better in the future once that subsystem has had some attention. So, I mean, I think the more nuanced answer is that there is more detail there in figuring out how the geometry of the robot influences what decisions to make as far as what velocities to set the winches to. But I think there's a pretty natural partitioning in that problem. Like, you have one piece that sets the flyer, or that tries to maintain a particular flyer velocity, or move the flyer to a particular kind of locally approximate 3D position relative to where it was. I guess it makes more sense to describe this in terms of velocities, even if the algorithm actually internally uses like a local representation of position. Anyway, I don't know if the camera is going to be framed. Oh, wow. I guess it's sensitive way over here still. So I was just moving around, and I mean, it is like a radio antenna. There are going to be places where it's more and less sensitive. I'm like way off the right edge of the frame right now. So yeah, there might be a different way we end up wanting to filter this data. It's sort of a representation of both the velocity and the size of objects in the vicinity of the robot. I have no idea how useful it'll be, but it seemed like even if we don't want to take motion based on it, it might be nice to use it to update the lights or something, so that maybe it tries to have like maybe unobtrusive lighting patterns most of the time, but if somebody is like maybe about to walk into it or walk near it, then the lighting kind of perks up and gets brighter. So something like that. Yeah, that was fairly smooth. I think a lot of the bumps that I was seeing was from it kind of really ungracefully managing the tension on the winch with the least slack, which was winch 3 just then. Anyway, let's move on. So I thought what we could really get into here was a kind of continuation of the Gimbal reverse engineering effort we were doing before. So we dug a little bit more into the Gimbal firmware in order to find out. Well, we've been in the Gimbal firmware a lot. I should say that this is certainly not the thing that we reverse engineered the Gimbal for. The reason we started down this road was to figure out how to control the Gimbal over its serial port. An alternative certainly would have been to just emulate or like an RC servo receiver and just give it PWM signals, just like it was designed for. But I would still need to figure out where the gimbal was currently pointing, and the best way to do that would probably would have been to tap into the magnetic angle sensors in the joints. So we could have done kind of a hardware mod for that, but the firmware mod was a software alternative, and it's proven to be a lot more interesting so far. There's a lot more in there we can tune, for better or for worse, and there are a lot of sensors that we get access to. Oh yeah, and the flyer has also been generating some nice data, if you haven't seen that yet. That's been going into InfluxDB. Let's hide, oh, not that. Oh yeah, I can also see what this looks like when we're streaming. Outgoing packets. Plenty of CPU utilization. Alright. Yeah, so this is the same data basically that we've been looking at before, just now it's over the course of 12 hours. Let's look at just the past hour. Then we can zoom into individual motion events, like take a closer look at what was going on there. And it'd be really interesting almost, yeah, maybe to get like some representation of the spectrum of the vibration on the accelerometer. Leo was asking what the plans are for covering the shell. Probably a 3D printed clips that fit onto the carbon fiber tubes, and then the clips would hold like either a plastic or paper, like a thin, like kind of arc, probably a half a cylinder, and then you snapped one onto each side, or maybe it's a single cylinder that kind of unrolls and just has a seam. But yeah, I think that could actually just be a cylinder of maybe solid color, translucent maybe, but mostly opaque material. And then I could even imagine making that out of maybe like lighting gels or something else, like translucent and like polycarbonate or something like that, that would bend a little bit. And then applying patterns to it using a vinyl cutter, maybe. Yeah, you could use construction paper. James is wondering, does this visualization thing have an FFT mode? I don't think that Grafana has an FFT mode built in, but I think the way I would probably implement this is, like, you're not even just asking it to do FFTs, it's like an FFT of a 3D vector, which is like, I think this is not designed to be MATLAB, but I would think what I would probably do even is maybe look for, like, part of me wants to know what the fundamental frequency is over time. Part of me just wants like a couple of filter banks where I look at, you know, I just like pick slices of the spectrum and plot them separately. So like right now, this flyer accelerometer plot, these three lines are X, Y, and Z. And if Y and Z look a little bit different than X, like part of that is probably due to the scaling because Y and Z are sharing an axis. So if I just look at X, or if I just look at Z, or just Y, Y is pretty noisy. And this is not in real units yet, this is still just like raw units at the moment for acceleration. But yeah, my thought is to really just, instead of looking at this by itself, to attach a filter bank and look at like low, medium, high, or like whatever granularity of different frequencies you want, you know, just have like a range of frequency bins that you could look at separately as separate traces. See this, like, we're adding a bunch of noise into the system by flailing around with the winches. Like, this is not even down to the physics yet. We're still so far into bug territory here. This is like, what are we oscillating around right here? I think that, I mean, that's got to be low force, right? Where's our force trace? That's way up here. Oh, why is my force so little? So like only 0 should be in low force right here. And so there's 0 in low force, but well, maybe the actual winch PWM isn't as jittery as the frequency is. Why is the frequency extra jittery? Maybe we're just oscillating around the, there's a threshold for winch motion. If the encoder is turning at least this fast, the winch doesn't need to worry about static friction, and it goes into the high frequency PWM. If it's below that, it goes into low frequency, and then there's a filter after that. We could just be jittering around that threshold, but it's happening pretty regularly here, which is interesting. Which maybe tells me that this is doing something weird to the motor's torque. Like it's having some effect on the control loop that's making it unstable. Anyway, this is also not what we're going into in this stream. I just kind of wanted to give you a taste of like, well, this is the kind of data we're getting. This is the kind of analysis that I need to go through and understand more thoroughly in order to figure out what to do next with making this thing more stable. And a lot of it really does just boil down to going through these graphs and actually making sure I understand all the glitches and where they're coming from and solving the ones that I can solve. Yeah, so we'll come back to this, but this is where we're going soon as far as, I mean, I might do some of this off stream. We might actually do some of this on a show if that's interesting. But yeah, this is the kind of debugging, like trying to figure out where all the squiggles are coming from. Oh yeah, once it starts actually oscillating, we get some nice wiggles on the pendulum, or on the gyroscope there. Is that... Yeah. See these velocity pulses? I think some of that might be just the force oscillations, because that would just make the cord in the measurement mechanism stretch and cause this to move a little bit. But I don't know if that's most of what we're seeing. A 3D printed lithophane. I don't know what a lithophane is. Oh yeah, that's a cool idea. Yeah, that's kind of cool. That might be a neat theme. And what about the frequency? If you're reading anything into the exact frequency the PWM peaks are getting to, then I really wouldn't. I don't see anything special about 10 kilohertz, so, and there really shouldn't be. Alright, well, I think it's time to dig into the disassembly then. So let's look briefly at the values that we found last time. So when we were digging into the gimbal before, it was actually out of necessity. It was misbehaving and it was just like rolling. It would just start settling into an extreme roll, and I wasn't sure how to correct it. It hasn't done that since I've nudged it back into position, but I don't know why it would have started or stopped that behavior. Like, my best guess is that this has to do with uninitialized memory still. But at least now we know which memory to actually initialize to get it to behave correctly. So if you go to Gimbal internals, we started to dig deeper into these parameters that only show up on the third microcontroller. So this is a graph of the memory space that the microcontrollers use for parameters and configuration related to the gimbal control loops. So this gimbal has one microcontroller on each axis. It manages the motor control and the feedback and the PID loop for that particular axis. And they all communicate via a daisy-chained serial network at, I think, 2 megabaud. And then if you configure the first microcontroller properly, either you can answer its serial ping in time, or in this case, we just modified the firmware so that it always starts up in this mode. The first micro can optionally be in this mode where you can talk to it over serial over the same pins that would usually go to the RC aircraft receiver. And so that's what we've been doing. And this is a system built into the bot controller that lets us kind of tunnel through the bot controller into that memory space within each individual microcontroller. So usually we'll just see the values that are being actively written or read, because the rest of them we just there's a pretty limited bandwidth here because of that 115K serial baud or serial link. So if we refreshed all of them, for example, it would cause the whole thing to be jerky while it actually gets around to refreshing them. So you don't want to do that amazingly often, but once you see that, you'll start to see, well, some of these are actually dynamic. So the magnetic encoder, well, we're not seeing this move right now because the gimbal isn't really doing anything, but if I flew the gimbal around, yeah, so you can see these values change. Some of these represent the outputs of calculations or parts of the PID loop. So these are two of the values we want to look at today. They're related to the motor control, but I'm not exactly sure what they are. They seem to be maybe complements or different phases. And so this is another example of a signal where we're getting each of these traces, like the red, green, and blue traces, each come from a different microcontroller. And this is just, so if we only look at this graph, this is what happens when we're asking each microcontroller, what do you got in parameter 6F? And we just send it a command on the serial bus, it responds, the Rust code schedules that amidst everything else that's going on, and then we're graphing that on the client side. So then if we start to look at this a little more carefully, like here I am just pitching slowly. And that moves in a sine wave. So I'm wondering if this is actually current on one of the phases of the motor. Let's try something similar with yaw. Okay, a little slower this time. Yeah, I mean, it needs a lot less current, it looks like, but it's doing something similar. And then roll is hard to test directly from here. I mean, well, we could use the new roll compensation values we know about. So the roll we found last time, that's starting to dip into a somewhat different way of using this memory, where instead of all the values being distributed between each axis, the values start to accumulate only in the last microcontroller, which is the one responsible for talking to the IMU. So you can see some of those show up here. Is that the... I think this is the IMU version. I should label that here. Oh, you know what? This is an old version of the web interface. That's why we're missing some labels. Do we have the new version? While the server's running. Yeah, that's better. Now now we have all the labels from the last stream. Okay, so this is the IMU type code. Let's refresh all this stuff once. Cool, so we've got just like a static background here for everything. This indicates what type of IMU we're dealing with, and then a lot of the other codes you can see, or the positions here where you have a non-zero number in the third column and the first two columns are 0, those are going to be related to the IMU or other parts of the control loop that are on the same microcontroller as the IMU. So then we started to see ways in which these parameters were read and written by serial commands. So up here, 5, 9, A, and B appear to be used as one 3D vector of some sort. These vectors seem to be using a different coordinate system than the other vectors. If you go by the microcontroller numbering scheme, then it's yaw, roll, and then pitch. If you go by these axes, it seems to be roll, pitch, and then yaw. Which I don't know why they made that different. Excuse me. Oh, I don't see Tuco. Oh yeah, that's a good question. The motors are indeed brushless. They're all three-phase brushless, and the microcontroller is just controlling them directly with MOSFETs. So it's also the motor controller. Are we missing our cat buddy? Maybe I'll just park this somewhere he'll be likely to show up. He's not on the couch, is he? He's not under the table. Oh, I could do video feedback with this. Wow, that's... The rectangle tracking is certainly taking to that pretty strangely. Okay, so yeah, these three seem to be used as some kind of calibration center point, like something they would set up at the factory. There's a command you can send that copies... Actually, we should look at that. It copies something to these values, but I didn't actually look at what the source was. So that might be a really dead giveaway to what these are calibrating for. And then these are the attitude correction values, which you can partially configure with the Windows application. I think these are only set to non-zero values because I was messing with them earlier to experiment, but usually these would be 0. So I could demonstrate the pitch or the roll calibration that we found last time. Let's point this at the fire extinguisher and halt it maybe. And one of the changes we made last time, or maybe the change, like, what does that sound? Oh, weird. The gimbal was buzzing, I think. Huh. So we made a change to the kind of general purpose parameter write routine here that actually rewrites writes to these attitude correction parameters to use a different serial command, because we found out the reason you can't just write directly to these, there's actually a floating point shadow parameter that the PID loop uses. Or, you know, whatever, I'm not going to say PID loop because we haven't actually dug down far enough to see that, but whatever coordinate transformation or control loop component in this microcontroller is using, you know, is responsible for going from IMU, kind of like integrated IMU motion to a command to the other axes to move. Whatever component is doing that mapping, which is part of what we're going to be getting into next, that component seems to do a lot of floating point math, and it uses the attitude correction, and they want a version of that in 32-bit float. And they don't want to do that every time they use the value, so instead they have a different, effectively, setter function, but in this case it's a serial command. So now we use that instead of the general purpose command. So it's also a little tricky to edit here because the range is really, really small compared to the range that these are very general purpose here. This is just like going to let me set any 16-bit integer, and these values are, I think you'd usually want them to be like under 100 or so. So you should be able to see it rolling right there. And I think what we want to do is actually look at the motor values also. Oh yeah. Huh. I put these labels position-like and velocity-like on here. I don't know how much I believe that versus whether they're like different phases or output versus sense. They have some relationship like that. I don't know if it's position and velocity. I'm doubting that label. But okay, I'm going to use the keyboard to adjust the roll correction while we look at this graph. That's really boring so far. I'm rolling very slowly. Oh, maybe did I lose keyboard focus? Maybe I did. Okay, now we're definitely rolling. Oh, can I not? I wonder if I can't actually operate a thing with the keyboard once it's off screen. Oh, maybe that's my fault. Maybe it's related to, it might need a request frame to happen. Anyway, we can get them on screen so I can be sure. I think something I did just unfocused that actually. Yeah, so now you can see the green trace is the roll motor, and it is slowly changing as I roll the camera. I think we actually want this set back to 0. Yeah, I haven't yet set this up to load these values from the config file yet, but that's coming. All right. Alright, so part of the goal of this is I want to be able to get the gimbal to be stable even in positions where it's pointed further down than this. Yeah, that's pretty far down, isn't it? The winches are not settling down on their own. I think they didn't like that tension. I'm gonna be responding to fewer comments on the stream. don't know, right now it's actually hard for me to be unhappy with the range of the gimbal. Like, of course it'd be nice if I could aim it straight down, but in practice this isn't really limiting me that much. A lot of the cases where I lose Tuco because he disappeared off that bottom edge, like, I wouldn't have been able to track him anyway because I would have been looking like directly at the top of him or something, and I would have been in gimbal lock in just a second anyway. So I think the thing that I'm more concerned about is being able to understand when the gimbal is unhappy so that I can have something automatically like shut it down or get it back into a safe state. So maybe the thing that's going to matter more is just figuring out what to sample to understand the current state of the motor and like how much power it's using. Relatedly, I don't actually know how to get from this parameter space back to just like a Boolean, is the motor on or off? So that's something I want, so that I can have some status like that. I don't currently know if the motor's on or off in the Rust software. Yeah. So yeah, last time we were in the IMU or the MCU2 code, which handled this block of parameters here, and its output was then I think this thing that I've been calling integrated IMU angles on Param 9, I think Param 9 is actually just flat out the output from MCU2 to that joint. I think that's how that works. But yeah, I think it's time to dig back into the disassembly. James is like, you may have as well have had a quadcopter with that noise. So first of all, this is all like not how it's supposed to be. This is a bug. And second of all, it's a lot quieter than a quadcopter. And whatever. It's like there's so many reasons why I don't want a quadcopter in here. I don't know what to do when, like, I just get the same, like, a couple of people monopolizing chat every day. Like, I feel like we as a society are told to value enthusiasm, and there's part of me that certainly values enthusiasm, but there's also part of me that just flat out distrusts enthusiasm. And then when the implication of it is that, well, it turns out that the chat is mostly just the same couple of people talking, then it frustrates me. So, like, yeah, there's my wet blanket moment for the morning. If anybody thinks that, man, the last thing I need is are fans who don't know the difference between fans and like something else. Alright, actually, I want to go back to MCU0 briefly and confirm that, just like write down some notes about command 0. Or did I? Let's see what notes I've already got about that. Yeah, like I've been really trying to just like answer everybody's questions and be really just like nice about everything, but sometimes I can't do that. Sometimes I just need to be quiet and grumpy and hack on stuff. Oh, did I not? Oh, that's right. I can no longer tab complete that now that I have SR macOS. Yeah, this... Was this Tuco walking across the keyboard or something? Or just me typing into the wrong window? Yeah, that is definitely a better explanation than... I would like to actually have the other repo in here too. Oh, yeah, I guess I could do that. I trust network mounts, right? Okay. So these are two different repositories because I have a separate repository that's really just my original reverse engineering notes from this project. And then I've been gradually kind of putting more of the substance of this in the actual bot controller. So like there's a Rust module here for the gimbal. There's some web stuff that has some more documentation. Gimbal internals. Oh. Wait, was that really 9? Okay. Cool. This is not an angle. All right, I think I need to get the gimbal to buzz intentionally to look at some data. I am interested in knowing whether the problem seems to be starting on the MCU2 side or on the per axis side. Well, let's get this closer so I can hear it. Hi. This is a little bit like having a small organism next to you. It sometimes loses interest. Let's have some more debugging here. It's getting a little buzzy. But not much more than usual. Yeah. That's where it gets bad. Or kind of bad. Bad enough that I'd want to avoid it. So, let's see if we can track down which side of the algorithm that's coming from. So... this is interesting. So I think, as far as I can tell, the way I'm actually commanding the gimbal is entirely per axis. Like, MCU2 doesn't know about those commands at all, which is a little bit different than how it would usually work, but not that different. MCU2 would get joystick packets normally, but it wouldn't actually be doing the motion. So that does move with the camera, but I don't think that this is actually how we're commanding it. Yeah, I mean, it moves pretty nicely in response to stabilization. The roll response is nice and fast. That's the green one, and it's staying very close around 0 because it's just responding very quickly, whereas the other axes, it's a lot slower in keeping it stabilized. Backseat engineering. Oh, cool. As Alex says, it's so cool to see it working. I've only been tuning in when you were having spooling issues. Yeah, nice to actually show this thing working when it's happy. Yeah, it's been running fine. I've just been debugging it for the past few days, really, but it's been mostly working. That's also a good example of how these inputs are wraparound, or at least for yaw it seems to be. So that's interesting. There's probably a baseline that's subtracted from that. Is that param 8? Because I bet that's param 8. No, that probably is related to the follow loop. Yeah, I don't know. I don't know if that is related to param 8. Is there some kind of flags? Yeah, I don't know about this either. Alright, let's make it buzz a little bit. I'm waiting for the graphs to rescale a little bit. Let's actually make this narrower. Oh, that's interesting. The yaw axis gets a little bumpy there. Try to put my fingers on the motor so I can feel which one is vibrating. With this little bit of extra damping, actually, it isn't... Oh, there it goes. I think that's pitch, as you'd expect, because pitch is the axis that seems to be really sensitive to our, you know, seems to be sensitive to pitch position. That's the blue trace you're saying. Alright, so I think this is good. I'm not seeing any oscillation in the blue. Let's see if we can get another trace once I'm going to try to get close and then let it auto-scale. Okay, now we got some oscillation. It's not the worst thing though. Yeah. Well, let's definitely look on the per axis side, because I think that's where our problem is. And yeah, and we can definitely point this thing down. The instability isn't that bad. I've just been keeping it limited. Let's see, that's getting worse. Oh, is that the roll? I think roll might have been starting to wobble a little there. No, I think that's still pitch. I mean, everything was shaking, but I think pitch was causing it. Okay. So let's basically do a binary search and kind of work through the signal path and look for where the problem is and where it isn't and try to see where it starts. So we just checked param 9. I think we are clear there. I think we have no vibration in param 9. So how about, I think near the end of this is like 6F and 70. I think we've already seen it in both of these, but let's just take another look. This makes it sure look like the problem is in those axes too, but I wonder if that's just a response to the vibration. I don't know. That does actually look like those axes are oscillating between 0 and some other value. Or, you know, closer to 0 and some other value. Alright, auto scale. I don't know why I'm seeing this show up in all the axes except for pitch now. And like obviously it could just be the graph scaling, but that's like why I'm waiting for it to rescale. And it looks like that is not as high amplitude as that. I mean, numerically it's about the same actually, so maybe it's just that compared to the actual... Yeah, it's a similar magnitude to the actual energy or whatever this represents that we're using to hold up the pitch axis under normal operation. So that's interesting. So all the axes... And it could just be that there's enough vibrational coupling between that, like once one axis vibrates, they all start vibrating. It looks like right there just roll was vibrating though. Now roll and yaw. It would be useful to know what these graphs actually represent, and I think that's a question we can answer by digging into the binary. .6F and 70 are the two that I found that seem to be motor correlated. See, what are you doing? Like, surely the buzzing would be noticeable on all the graphs. Why are you so sure? What is there to be sure about? I think, like we were just talking about the reasons why that might not show up, like either because that's not part of the control loop that is participating in the vibration, because the vibration's on a different axis, because the graph is scaled wrong. Like, there are a lot of reasons we might not see it, so we need to control the experiment carefully and not just dismiss that. So, I mean, we might as well keep looking at this on MCU2, because that's the file we've got open, I guess. But 6F and 70. Okay, these are already labeled motor 1 and motor 2. Is this really the only reference to them? If we're only storing them once, then that would just indicate to me that these are not really used to communicate from one subsystem to another, but they're just sort of stuck there as logging. So like maybe these RAM locations are actually the motor control data structure of some sort, whatever this is related to, and this is just kind of logging it so that we can see it from the PC side. But I would like to rule out, like, that's probably what's going on. Before I go down that path, I want to make sure that we aren't missing the potential for other uses of these variables. So I'd like to just make sure that we have all the cross-references to our param space sorted out. What's this? Is this the IMU version 6.9? Yeah. These I have unlabeled 6A. Those might be unused. Interesting. Like maybe they had some other structure in here for the motor. Like this might have been something where they had an earlier product that had a slightly differently constructed motor controller, and they wanted the same software to be compatible with that firmware. They might have left these slots empty, or maybe these slots are used on the other MCUs. I just wouldn't have otherwise expected them to leave gaps, so this might indicate that we're missing some cross-references. Huh. Why are these not named right? What? Why don't these line up? I hear you, Tuco. I should really put that limit back before I let the gimbal run on its own. That's definitely param 0. Did I just label all of these wrong? Tuco's exploring boxes. Oh, that's right. Renumbered all these by machine, so they're not going to be incorrect. So where was that problem before? It was around 20. Just put a few labels in here now. Alright, where to next? Maybe just dig back into this area around 6F. So what is this sub? Okay, so we're in systic. So this is a periodic timer. It's often configured to go off at like 1 second or like a small fraction of a second. Just like kind of a coarse-grained timer. I don't know exactly how they have it set up here. That's interesting. What is systic specifically just doing here with the parameter space? So that's the motor thing we were just looking at. This is another motor thing. So the systic IRQ might be used entirely for their motor driver. What is that? Ah, this is the off-center calibration point. Yeah. That's Cal 1, which is a bit of a mystery I'd love to solve. Cal 0 is 4D. What's 2C? Oh, magnetic encoder position. So this is getting the current position relative to the calibration point 1 on that axis. Sign extending, comparing, rollover. Huh. So RR0 is the current position of this axis relative to that saved point, which is a bit of a mystery what that point is, but it's probably something related to one of the motor phases. And then handling wraparound, because those are all modulo 4096 optical or magnetic encoder positions, so that's what they're doing here. Let's just call this cystic body. And then we're doing something with the PC attached flag, which is interesting. It looks like I would expect this to be something where they allow you to override the motor mode when the PC is attached, but when the PC is not attached, it's always 0. Is that what they're doing here? So they're comparing it to 0. If it's equal, it is 0. If it's not equal, it's non-zero. So the two thens here are a non-zero. So if the PC is attached, yeah, that checks out. If the PC is attached, we allow reading this, otherwise we assume it's 0. This is probably for some kind of testing or calibration mode. Like this might be like a factory test enable or something like that. And then different motor modes. This is skipped when it's equal to 3. Oh no, sorry. Yeah, this is case 3. It's always a bit of a brain puzzle decoding all these optimized conditionals. It's like, it's always hard for me to distinguish between just like two otherwise identical cases. I have to like double and triple check in my head. Like left and right and 1 and 0 and all those binaries when it might as well be either. So this is the case for not 3. If it's 1, then if it's not 1, we run these 2 instructions. If it is 1, we fall through to the same case as 3. Oh, or 5. Okay. So there's probably an enum of several different tests that they run through, and only in some of those tests maybe we turn on the motor even. It would also be really nice to see how motor power on actually works. That could be really related to some of the parameters we end up caring about here. Yeah, and then 27. Oh, what is that? Oh, that is a static parameter that is usually 16384. A. We'll label these differently when I figure out what they're actually for, but oops. Right now it might just be useful to know what their value is at this point. This is this like a 64-bit divide or something? Well, let's come back to that. Okay, I want to take a couple notes here. I do want to keep track of sys-tick body. I'm also just really curious about motor on-off, actually. I might go there right now, because I do want to know just... I don't think those actually go directly in param space, and I would like to know what memory area those actually mess with in the context of this code, so I'd like to have that in mind when I come back here. Sys-tick body and off. Let's take a look at on-off. Which command is that? Command 3. Alright, so this is serial 1, handle packet. Command 3, motor on-off. This is like some kind of like cast to Boolean, so it's taking it's like checking to see whether it's 1. Oh, what is this specifically? Okay, so we're subtracting 1 SBCS. I'm gonna have to look up the next couple instructions. I think MVN is moved negative, so it's like complement, but I forget what SBC is. Oh, subtract with carry. That's it. Oh yeah. So they're just using this to convert that to a carry flag, just subtract it with it from itself, but get the carry flag that we set up here. So I think this is just testing non-zero-ness. Like this looks like what a C compiler would get if you cast something Boolean, but I was trying to see whether it was inverting or not, which would tell me whether it's Boolean cast or like the not operator. And I think that's the not operator, hence this MVN. And then we're taking just the top bit. Yeah, this looks like a not. So why would this be not? Are they going to initialize this with 1? It would just surprise me for them to have a global variable, which is effectively, is the motor disabled? Where are we? Main. That's interesting. Like, so this is pretty late in main. This is right before the main loop actually starts, after all the initialization. And we're calculating a value for this motor is disabled using the same instructions, so it's like the same like C operator probably. And that's coming from R0 right here. So R0 here is motor is enabled. So this block of code would be, Why would we be doing something else with the joystick if the motor is disabled here, and where would this come from? I assume this is some configuration thing, like if the motor is enabled on startup. Which is different depending on whether we go through the PC attached loop or not. It's also just interesting how it's writing to this through a pointer. Like, it's probably just some shared global variable. Shared global structure. Or is that just a simple base address I'm missing? Maybe that's this. Maybe it's D50. Oh, there's PC attached. Oh yeah, I think that is PC attached. We just missed the base address. Cool. So much float. A lot of those strange numbers are floating points in hex. Yeah, so we're skipping the joystick. So if the PC attached, then this R0 stays 0, which means the motor is disabled. Is that right? No, this would be 1. So how does that end up here then? Oh, do we not negate this? Oh yeah, there's no negation here. Great, that's actually a motor is disabled flag. So that serves dual purposes. It's loaded here from PC attached, but it's also used as a motor disable flag. And here, it's just initializing the joystick mode. And what is this? That's 38. That's param 63. Ah, that's turning on the follow loop. Or turning off, sorry. Yeah. Neat. That's not useful right away, but it's good to have that out of the way. Oh, and then zeroing out params 3, 8, 66, and 53. 66 is the joystick mode. 3 and 8 are some of the nice like input control parameters. Like, yeah, 3 is the commanded rates from the follow loop. 8 is like an integrator for that. I don't know exactly what 8 is, but it's something that like integrates the current status of the follow loop. 1F40 goes to 1B. Huh. So these are reinitialized every time the firmware starts. I don't know what that is. Alright, what else is nearby here? some flags. It's kind of near the main flag stuff. Okay. Back to systic, I think. Or maybe, who else uses this flag? Huh. Wasn't expecting it to be used twice in here. Motor toggle, maybe? What's in R5? This is weird. This is also a little unwieldy. Let's maybe look at this in the linear code. Oh yeah, so I guess there's a way to turn the motor on and off with the joystick, which makes sense. I hadn't looked at the joystick packet format that much, but there's like a mode byte at the end, and so maybe there's a way to use that to turn the motor on and off, and it looks like there's a toggle in there. So okay, we have two references to this motor disabled flag in the command processor, one for joystick commands, one for command 3, which comes from the PC. That's how we've been turning the motor on and off. Alright. And what else? Just these subs up here. So if the motor's disabled, we run these 4 instructions. What are those doing? Param 1 and 2E. Huh. Yeah, no idea what those would be. So if the motor is disabled, we load params 1 and 2E, then check whether they're equal, or check whether 1 is equal to the negative of 2E. One is usually 0. And 2E is usually minus 32k. Ah, that's interesting. I don't know what that could be for. So it's like there's something that we might want to do even if the motor is disabled with the motor. So then if not equal, then we branch here. So this is the motor enable path. And this will be motor disabled. And I assume this is like a PWM register. Let's get the data sheet handy. More tea. My tea is empty and it is cold here without tea. I'm going to refill my tea, and I'll take a look and see if I can find Tuco. He might have... Oh, he's in the couch. How did I not notice him in the couch? I figured for sure he must have retired to warmer quarters. Brr. Let's get something from the refrigerator. That'll help with the warmness. Does anyone else like kefir? I was like vegan for a while, and so I wasn't drinking any dairy, but lately I've been back on dairy, and as far as yogurt drinks go, it's pretty delicious in my opinion. I always overfill the tea, and then I have to be really careful in bringing it back to the desk. And then inevitably some of it's gonna spill anyway. Maybe more heat. Brr. Let's try that. More heat, more jacket. I might switch back to the stationary microphone if I'm mostly going to be at the desk here, just to save my head from getting pinched by this thing. Brr, how's that? Yeah, Tuco is looking pretty comfortable there. Yeah, let's drink something cold. Alright, where's that memory map? C20. That's time 1. That is time 1 CCER. Oh, now I'm just cold. CCER. Okay, this is it. This has the polarities and enables, so they're using the capture compare outputs to do the motor PWM, so this is how they're going to be enabling and disabling when the motor is actually turning on and off. So that's interesting. That means that this motor on-off switch takes place really late in the cycle, and the control loop is still going to be figuring out what values it would have been giving to the motor and just not turning on the PWM, it looks like. So that makes it handy for them and for us to debug this thing, I think. Son of the Cake says, as my husband said, you need to be passionate in order to watch 3 to 7 hours of someone's programming. I don't know if I usually... I don't know. Like, if... I think the way a lot of people use these streams is to just, like, co-work with them. Like, they'll be doing their own thing and also listening or kind of halfway paying attention. And I like that a lot. And I don't... Like, being passionate, sure, that can help, but I don't think it's required. I think I'll certainly just like watch stuff that I'm not necessarily passionate about, but just find interesting. So if you're not passionate about this, but you just kind of find it sort of interesting, then like, that's fine. You're in good company. Alright, so 5, 5, 5, what does that do? It's NE and E. Are these active high or active low? I think that means it's enabled. So these are the enables. Is this really motor disabled? Because we're setting those flags and setting, I mean, Did I get that wrong? Motor's disabled. Maybe I got the polarity here wrong somewhere. So NP is just a polarity switch. I mean, NP and P are both polarity switches. So that's just, this AND mask turns off all the enables. Yeah. I think this is just backwards. This is like what it would do to disable the motor. Alright, then what's going on here? R2. What's R2? That seems like a useful base address. 78. Yeah. Param 28. That might be what I want. Huh. Really? What does Param 28 actually look like? These might also be motor related. Oh, I already have notes about this. Motor phase offset estimate equals approximately 16,000 at the cal at one point. Possibly that's equal to 27 at the cal at one point. Okay. This one. Okay, that's reasonable. Then we're zeroing these two parameters if the motor is disabled and setting 1 to this one if it is enabled. Okay, and so where are we again? This is... We need to understand the code around here to understand the motor, probably. Are these motor modes? Yeah, these are motor modes. Be a little verbose there. Motor enable or disable in current mode. Oh, what's R5? So we've got motor mode and R5 are our two inputs here. I'm pretty sure motor mode is usually 0. 0 is normal operation, everything else is like calibration or factory test or something. Oh, motor mode is 1 right now. Maybe PC attached is usually 1. Can I change it to 0? The yaw axis just went limp, so 0 is off. 1 is... Oh, that's kind of nice. Do these... I don't think I can rely on these to change when I turn the motor on and off, though. I don't think I can use these as feedback. If I turn the motors all off, do these go to 0? No. But that was exciting. Oh, here Grumps likes the hat, thanks. Yeah, this is interesting. Let's keep digging from this point. So usually motor mode is going to be 1, but it could be 0 through 6 or something like that. Huh. That's interesting. Motor mode 5 seems to go right back to motor mode 1. I wonder if it's like an increment thing, like you can push a button to increment the mode during some test harness they have. You know, I wonder if these modes are actually how, like, maybe each one is actually a feedback loop that causes the gimbal to self-align to a particular position. I wonder if that could work. You'd still need some kind of external reference for cal 0, but maybe that's how they get to cal 1. Is this like a debug value or something? Nobody reads it outside this function. So not much happens in mode 1. Like, these other modes seem to have some special processing. Like mode 2, that uses 4E and 4F. So in normal operation, this doesn't do much. Let's resolve this R4, that's C4C. Yeah, so what about this R5 thing? Did that just make it all the way down here? Any changes? Only in mode 2. That is interesting. So just naming those so I know that that has something to do with motor mode 2. So I thought that might have something to do with setting up the PWM. All this does is enable and disable. It does tell us exactly where to look for the PWM though, because this is just timer 1. And if we were to look at like the timer 1 phase registers, we could probably find this. Just look for literals in that neighborhood. I might also just look for functions that are nearby in the binary. So I switched to linear mode here, and I'm imagining that they have just like one .c file that has things related to the low-level interface for the motor. So I imagine this might be pretty close to the motor enable disable function. And systic, the systic body here is actually in that same vicinity, so this might even be technically part of their motor controller rather than part of their like systic kind of infrastructure. Let's zoom in. Oh, these have some refs that are not actually. Oh, that's somebody's. I have not seen a lot of people like pass around structures by pointers in this code base, but that's what's going along around here. Like a lot of global variables and stuff that are very, very easy to reverse engineer. Not a lot of complicated data structures going on. Is this a lookup table? Is this somebody's big old lookup table? Yeah. This might be a sign table for the motor driver. It's probably supposed to be 1024 instead of 1026. Maybe. It might have actually needed to be slightly more than a round number. C9? Oh yeah. Yeah, no, I think they made this a little bit longer so the wraparound cases would be easier to deal with. I think this is actually 1026. We could plot this to see what actual function this is. I'm guessing it's a sine or some other trig function. It could even just be the lookup table that they use to actually just generate, like there could be other parts of the motor control baked into this table, and they could use it to go right from like angle to power. Is that GPIO? Wow. Might be easier to just approach this from systic. Okay, we're doing a lot with parameters here. That's nice. $16.50. So these are the inputs coming in through, or this is the input coming in through global variables. What is that hardware? 4001, 2400. Is that GPIO? I'm going to ask that about every region. Are you my GPIO? Oh, that's ADC. Oh, yeah, that's the ADC. Nice. ADC here is probably going to be current feedback from the motor. Assume this just starts the conversion, but this is storing that gated and shifted right. Really? Why? Is this the right register? This doesn't make sense. What looks like it's going on is we're passing, I think this is the this is the offset to ADC1. It's also the offset to the ADC1 status register, because that's the first register. We're passing that and 480 hex to this function, where this seems to be shifting right by 8. So it's like discarding the bottom part there, and then it's just looking at 4, negating it. Is this 2's complement, or this is, yeah, this is 2's complement negate. I'm assuming this is clearing a conversion flag, and this might be set, or this might be called through the ADC1 interrupt, maybe? Interesting. This doesn't quite make sense to me, but maybe I'll come back to it in a bit. Okay, it's like a Sudoku puzzle or something. It's like you could just keep working at one part, but sometimes it helps to move around. Data register, J data, injected channel data. What are injected channels? Probably doing something specific to trigger the ADCs using the hardware timers here. What is injected conversion? Is this like a general ADC thing that I'm missing? It's an STM32 thing. One of the most advanced ADCs. Oh, so there are like multiple priorities for ADCs, it looks like. So you can ask it to do a particular conversion asynchronously, but then there's also, like, for example, this could be a periodic sample that happens via hardware, and I think they just have separate places to store the results for each, maybe? That might explain why they have different registers. Why is IDA not annotating that? It's right there. The compiler didn't really make a lot of attempt there to use one base address for all of those, did it? 3C? Is that the next ADC? Yeah, that's ADC2. So 2 channels for 2 phases, I assume? And 40... Oh, are we using the low 16 bits also, or low 8 bits? Great. I guess now I need to know what the difference is between JDR1 and JDR2. Those are different channels. Okay. So 4 of these ADC inputs. Interesting. Oh, that is the ADC interrupt. Cool. This has got to be like a some kind of acknowledge routine. I don't get the shift and the negate. It's just like somebody's weird API convention or convention. What are these? R4 and R5 are different peripherals, I guess. Yeah. I think that's also ADC related. Let's just call that ADC acknowledge. Just going to maybe label some more of these ISRs. Actually, I should take a quick restroom break. I will be right back. Let's get this on a better view at least. Warm tea helps. It's still cold here. Oh yeah. Yeah, such a good cat. Of course, the first choice is, well, there are 3 different vector tables. There's extra large devices, connectivity devices, and other devices. I think we're in other devices here. I guess we can have a little bit of computer here, but it's nice having full screen Tuco sometimes. That's 1, ISR for ADC is 1 and 2. Huh. This is the CAN bus ISR, unless I'm reading the wrong table. It wouldn't be unheard of for a gimbal to support CAN bus, but I haven't actually seen any evidence of that, so maybe this is the wrong table. It's 9.8. That seems like a CAN bus interrupt. Interesting. I wonder if this is just some kind of stub. And this is just, like, transmitting some replies or something? I don't know. Whoa. What? This is somebody's CAN bus library. Let's just make sure this is CAN bus, but I think that's CAN bus 406404. That is CAN bus. Some kind of unknown giant CAN bus related switch statement. Yeah. So for anyone who isn't familiar, CAN bus is a multi-drop serial bus that's common in automotive applications. It wouldn't be unheard of to use this for something like the gimbal, so I'm not surprised there's some kind of support for it, but I would have expected to see it by now because I would have expected it to be more interconnected with the serial command passing system. So I don't know what they're actually using this for, if anything. It might be something else they're using for factory test or for other products. That's timer 1 break, timer 1 update. Timer 1 capture compare, and then timer 2 global. CC, that's SPI. I think SPI is how we get data from the magnetic sensor. That starts some bit banging, I guess, to finish up the transfer. So part 1. What is F4? F4 is timer 8? Trigger and commutation inputs. I didn't see timer 8 anywhere before, so this is new to me. Timer 8 TRG com. ADC3. Really? Oh yeah, that's another ADC acknowledged. We're just not doing anything except acknowledging that. That's probably left over from some other iteration of this product. And then 2 more. 118 and 18C. That's times 6 and times 7. And some data. More data tables. Oh, 1026. It's probably another trig table. $20.49. All right. So what about time 6, time 7, and time 8? Timer ACK. Those are stubs. It's time 6, 7, and 8 don't seem to be doing anything. Same with time 1 break and time 1 update. Time 1 CC. Interesting. Huh. Here's time 2 checking out the motor mode again and checking for motor mode 6. Oh, I'm getting carried away and about to be, yeah, I need to make sure I actually wrap up the stream soon enough to make it to some dinner plans later. I was distracted earlier while I was trying to figure out what time they were. Yeah, actually, I've got to wrap up really soon. I'm glad I noticed that when I did. But, yeah. In that case, sorry I've got to cut this short-ish, but I've got to go do a thing with some humans. Yeah, I know. I'll probably survive. It'll probably be fine, actually. Yeah, so, I don't know. That may or may not have looked like much progress to you or to me. We're getting a little deeper into figuring out what's going on with the motor controller and where to look here. And we did conclusively, I think, determine that the kind of buzzing problem is related to the per axis side of the control loop instead of the kind of general purpose stuff on MCU2. But yeah, we'll have to dig in deeper. This is getting pretty interesting though. Like, we're starting to unravel enough of the pieces to where the motor controller could start to make sense really soon. So it's also interesting to just have so many different implementations of math functions here. Like, we've got 64-bit floating point. Like, this function right here is a 64-bit floating point sine cosine, and we have this. We've also got like fast 16-bit fixed point stuff in lookup tables, just because of the different frequencies we're dealing with here. Some stuff needs to be fast and some stuff doesn't, but yeah. All right, I'll have to sign off, but I'll see you folks next time. And yeah, happy hacking, everyone. Thanks for everyone who tunes in and offers their support by, sending some money my way to help me pay rent here, and keep the streams coming as often as I can. People who send in hardware or just tell their friends about the streams or about the edited videos. So yeah, thanks so much, and I'll see you all next time.